Today we will discuss the topic double refraction. We know that refraction, it is the phenomena in which the light, when moves from one medium to another medium, it don't move in a straight path. It bends towards the normal or away from the normal. It depends whether it is coming from rarer medium to denser medium or from denser medium to rarer medium. This is the example of single refraction phenomena. Single refraction phenomena takes place only when the mediums which we take are isotropic in nature. What do you mean by isotropic nature materials? It means their physical properties and their chemical properties, their magnetic properties, their thermal properties, their conductive properties, they didn't change with the change in the direction of the substance. For example, if we are taking an isotropic material and let us consider these are the arrangement of atom, molecules or ions in the medium, then if we move from this direction, the effect will remain same whether we are moving in another random directions. But in case of anisotropic materials, the refraction is not a single refraction. The phenomena of refraction becomes the double refraction phenomena. In this case, with the change in the direction, there is a change in the distance between the atoms, molecules and ions. For example, if we move in this direction, this is the distance between the particles, atoms, ions or molecules. But let us consider if we are moving diagonally, then the distance will change. If the distance is b, this distance a is this b. It means with change of direction, the properties of the material and isotropic material changes, and due to this anisotropic behavior, the diffraction moves from single refraction to the double refraction. Now we will discuss about the double refraction. For example, we are taking a tourmaline crystal. It is a anisotropic crystal. Then in case of this anisotropic crystal, if we are, let us consider we are taking, this is our tourmaline crystal and this is any sim point or any dot which we are taking on the paper, and through this tourmaline crystal we are viewing this, we find out that we obtained two images of this single point, and this is the double refraction phenomena. In this case, one image is known as ordinary image and another image is known as extraordinary image. In ordinary image are formed with the help of ordinary waves or ordinary rays, and the extraordinary image is obtained from the extraordinary wave or extraordinary rays. There is a difference between extraordinary wave and ordinary waves. First difference, we are taking the velocity on the basis of velocity. Velocity of ordinary waves remains constant. It does not change with the change in the direction, but the velocity of extraordinary waves changes with the change of direction. If we change the direction, the velocity of extraordinary wave changes. So we will discuss about their refractive index. Again, the refractive index, as the velocity is constant, refractive index of the ordinary waves is also constant. But in case of extraordinary wave, as the velocity is variable, therefore the refractive index is also variable. It also changes with again the change of direction in this case. Now we will discuss about their polarization nature. Let us consider we are again taking an anisotropic material or an isotopic crystal, and we are using this crystal to study the polarized behavior of the waves. These ordinary and extraordinary images have a separation in between them, and this separation depends upon the thickness of our crystal taken. The distance between these two images increases with the increase in the thickness of the crystal. It means if we have a small distance in between them, the thickness of the crystal is small, and if the separation in between these two images is large, then the separation is also large. If we discuss about the polarized behavior of these two waves which are forming the ordinary image and extraordinary image, the ordinary image wave vibrates perpendicular to this paper. It means the photons of this wave move like this, and in extraordinary wave the photons are moving on this paper. It means they are moving parallel to this plane. Ordinary wave are perpendicularly polarized about this paper, and extraordinary wave are parallelly polarized about this paper. Now we will discuss about the calcite crystal, which is an example of an isotropic crystal, and it will show the phenomena of double refraction. Let us consider this is our calcite crystal with 8 corners, and from these 8 corners there are 2 corners such that the angle in between the surfaces of this crystal, all angles are obtuse in nature. Similarly, this is also a corner at which all the 3 angles are obtuse in nature, and it is approximately of 102 degree, and these 2 corners are known as blunt corners. The condition for the blunt corner is that all 3 angles are obtuse, and the axis which connect these 2 blunt corners is known as optical axis. It means it is a direction. It is not a line, it is a direction. It is an imaginary direction through which we consider that when the ray is allowed to fall about this optical axis, there is no double refraction. Only the phenomena of single refraction takes place. This is the